So where are we? I think we are assembling this new banner in this, putting this new banner assembly in here. Go plop it in there. Make that a part. And connect it. So I haven't actually changed my transmitter. All I've done is plug and play a different component that realizes the same interface. I should be able to make that. And run it. So this time when I run, I actually get a different implementation for my receiver. My receiver effectively has a collection of letters. Each letter has a collection of pixels. Refresh is being called on each of those pixels every 10 milliseconds-ish. And that causes them to move from left to right. The key thing is my transmitter did not have to change for me to put a completely different implementation of the services it requires. That's what ports and interfaces are all about in UML2. It's about separation of concerns. So we decouple components that require services from the provider of those services. We can use, effectively, the modeling tool to automatically assemble those components together. It provides not only the generate not only the behavioral code and the interfaces and such, it'll also work out all the wiring between them. It's a regular pattern, effectively, that can be automated in the generator. Now here we come back to Ada. So what's the problem so far? Well, everything I've showed you so far works with Ada 95. I can use an abstract null record, effectively, to represent an interface. The problem with Ada 95 is really that Ada 95 doesn't permit multiple inheritance. I can't easily support multiple inheritance with Ada 95, which means that some of the UML2 notation that was developed heavily on C++ cannot easily adapt to, well, cannot adapt to Ada 95. So some of this clever wiring that UML2 supports becomes unusable. And of course, subsystems in general are complex beasts. That's why they're subsystems. We would expect them to have multiple interfaces. We would expect them to have multiple ports. So in UML2, a class can have multiple ports, and a port can be typed by multiple provided and required interfaces. A strategy for solving this problem is the adoption of Ada 2005 interfaces. Ada 2005 introduces the concept of an interface, which is a collection of operations, effectively. We interpret that as a collection of operations that act on a particular tagged type, well, implicitly tagged type. The great thing about this is that it supports multiple inheritance. A type can be derived from multiple parent and progenitor types. Someone will have to explain to me why we need that term. So I can support the full UML2 syntax for ports and interfaces using a mapping that includes Ada 2005 interfaces. So from a modeling perspective, it opens the door. It's an exciting introduction to Ada that allows Ada engineers to exploit the full breadth of UML2 notation for ports and interfaces. So I can use a graphical notation, I can use collaboration and advanced tools like Rhapsody in order to build my systems. Another key thing that I find is the compiler feedback tends to be very strong when you have a concept and interfaces. I've actually built the same model with C++, and the compiler throws some funny warnings because C++ doesn't have the concept of an interface. So you get very clear feedback. The idea of Rhapsody is that model code at this level, we might have an abstract system model, but at this level what we're talking about is the model or the diagrams being a view of the code. A view of the code for developers to work more productively in. They can work in either the code or the model. They are kept automatically in sync. They never digress. So we can exploit what we call model-driven development to build applications faster. So what's the aim of this? Well, fundamentally, we're trying to create software faster. We're trying to use advanced tools to improve the speed at which our people can communicate with each other. Because software is built by people, not by tools. If the tool can do something automatic, which the people would always do the same way, okay, we can get the tool to do it so that people can concentrate at a higher level of abstraction. They can work faster. Especially here, we're looking at predictability, consistency, quality. If we can get the code generator to do something, it will do it in a consistent way. If we get people to do things, they don't always do it in a consistent way. But fundamentally, these are the aims of what we're trying to achieve. Better software, faster. So, I won't do this. This is kind of a chronology of Ada versus UML. I think the interesting thing is, actually, if you look at UML here, UML has gone from object-oriented, pure, to structured design. Ada has gone from structured design, well, sort of structured design, to object-oriented. So it's a good time for these two technologies to come together. Thank you very much.